Hello everyone, welcome to the course Formal Languages and Automata Theory, lecture number 9. In previous lecture, we have discussed about designing of the deterministic finite automata for a string starting with A. Similarly, like that, we are going to design a DFAs with containing A and ending with A. Yeah. Construct a DFA for the string over A comma B, where each string containing A. First, we have decided what we need to do. First, we need to construct the language which is going to accept this string containing A. L equal to A, AA, AB, BA, AAA, ABA, and so on. And it is an infinite language. It is an infinite language. And when you're going to observe the previous example and this example, here containing A means in the string anywhere A can present. It is not to be considered A should present at the beginning only. A can present anywhere. At the starting, at the beginning, at the middle, anywhere it can present. Right? Now, this is the language we have written. Now, what is the next step we need to do? We need to write the skeleton for this language by taking the minimum string. What is the minimum string here? Single A. Now we are going to represent Q0 is the initial state. By seeing A, it reaches the final state. That means here A is representing the end of the state. This is one. And coming to the next one. Is this a DFA? No. Why? For each state, all the inputs should be represented. For Q0, here still B is not represented, and for Q1 also B, A, B both are not represented. Because of that, this is not a DFA. Now, if you assume that if we are going to have A at the ending, by seeing A at the ending, you reach Q1, right? You have something before. Now, when you are going to observe, suppose I started my string with B. I started my string with B. Then what I need to do? After seeing B, I can get my A anywhere. I can get my A anywhere after this B. That's why I am going to accept this B. I am going to accept this B. I am waiting for B. Now, this is a situation where we are going to get B, A. If you are going to have the string BA, that will be accepted. Otherwise, if you are going to have any number of B's, and after that, if you are going to get A also, this is going to be accepted. Okay, this is one of the string that was present here. Next, coming to the next one. Suppose I have BA. I am going to consider BA that was present. After this A, here the question is containing A. Because of that, already you got one A here. After this, whatever you are going to get. After this, whatever you are going to get, you have AAA you can get, or ABA you can get, or BBA you can get, anything you can get it. That will be accepted. That means you are going to represent it by A comma Now you observe whether this is a DFA or not. For Q0 we have A and B input symbols represented, and for Q1 also AB input symbols represented. Now it is a DFA. Now one more thing what we need to check. We need to check whether the string is accepted or rejected. Both the things has to be verified. Why means whether the string is not in the language, if it is also be accepted, then this is not a DFA. To show that, we are going to represent string acceptance and string rejection. If you are going to consider string acceptance, that is BA, B, A, B. Now, the initial state is Q0, Q0 on B, Q0 on B, it is in Q0 state only. Q0 on A, it is moving to Q1. Q1 on A, it is in Q1 only. Q1 on B, it is in Q1 state. Here Q1 is the final state, that's why the string is going to be accepted. Now taking the another string DB. Now if you are going to take Q0 on B, it is going to be in Q0 state. Q0 on B, again it is in Q0 state. And here Q0 is not the final state. That's why the string is going to be rejected. And if you are going to observe, this DB is not present in the language. Right? In this way, we can represent the diagram for DFA for given string over sigma equal to A, B. Thank you.